So I have gone ahead and changed the configurations in the custom configuration file. So earlier I was running this with some batch size of I think one and subdivisions also one. So that obviously is not correct. I did not really understand what this is. I was just fooling around with it. I did understand what batch size is, but obviously subdivisions I was not aware what it is. Subdivisions is a which is unique to YOLO. This kind of thing you don't find in PyTorch or elsewhere. Like for example, the learning rate and all you'll find in PyTorch, the optimizer stuff you'll find in PyTorch, right? So that optimizer step and all that which is there, uh, the scheduler, the optimizer. So these things are common, with PyTorch. So that's generally the generic or rather journal implementation of how you would train a neural net. But this was new, so now what I've done is I just have about 15 files over here, right? So there is nothing much over here, just 15 files or 14 files, and so I've kept the batch size as 6. So now what will happen is when I go in a 2, so it will actually send 3 images in for each iteration, and width I was using earlier 416. So that 416 probably seems to be the uh, default for YOLO, right? So that is what it is. But for now, I'm using 64, and so I ran one test earlier also. So I'll just come to that. Over there, I kept these values lower. The channels is 3, obviously RGB and all that. That momentum is used to penalize large weight changes between iterations. So if there are large weight changes, we might end up overfitting, or there might be instability in the training. To penalize that, this is what is done, and then decay is also uh, required for you know overfitting. So I found one blog where I read all of this, so I've just quickly updated. So this again, if the learning rate is too large, the algorithm will overshoot the global loss minimum. If the learning rate is too small, uh, yeah, if the learning rate is too small, the algorithm will require more epochs until convergence, uh, which can make the learning slow, especially for large data sets. So I don't have a large data set, so I could risk having a larger value for learning rate, sorry, or a smaller value for learning rate. So the smaller value could be what is recommended is I think around this. Yeah. But now what will happen is when the learning rate starts at this, it will keep on increasing. So how will it increase? That it'll increase um when these values are reached. So uh, 200 is what we are running for. We are running for 200, aiming for 200 batches. When 20 and 50 are reached, then the learning rate will increase. And how will it increase? That will get multiplied into these two steps. So I could have these two steps uh, just to experiment. Maybe I could have this as zero point 0.5 and maybe have this as 0.25. So that when that change happens, maybe we'll notice something, right? Is what I'm thinking. The rest of this down below obviously is got to do with each and every specific layer. So this is just what I had done earlier. So this I am obviously not changing now. So I'm just looking at this, and that for testing, and this is for training. So this little bit of configuration about say 10-15 lines is for training. Okay. Now what I have ran earlier. So I got within backup. I got this. So this one I had to stop because it was not going too well. So I stopped it. But the next one I'll let it run through, and it has given me last weights also and final weights also, right? And that size remains the same, 256 MB, 256 MB. So even though maybe the training is not very proper, or maybe things are not going well, but the size seems to be the same, right? Then I had those two chart this thing over here, but I think those vanished somehow. I'm not sure how, but I had those two chart files over here, so we could have seen that, but that's okay. We'll run it again, and I'm sure we'll get that. Okay, yeah. So this is how it ended the last run. So it said saving weights to backup. Okay, so these two weight files got saved, and if you want to train from beginning, then use the flag in the end training command. So yeah, so haven't tried that yet. Mm, okay, so few configuration changes. Let's see what happens now. I'm still not done with the entire configuration part of it, but let's check. Yeah, so this has been given as 200, right? So that value, the max batches, that is 200. We can see it down here, right side bottom. And now it is on iteration 100. It will go only till 200. So then whatever gets saved, and then it will quit. Right, so it's already 156, 100. So this is obviously, just playing around with this. This will not get us good results, but naturally. So it is saying it got saved, and again, see it comes out. So it says 1200 images. So obviously it is taking my images, those 15 images, and it is running it in batches again and again. It has reached that value of 1200, and now it is saying on 200 it is giving me this, right? Mm, mistake. I shouldn't have. I should have copied that last bit so that we could have compared. Did I copy it somewhere earlier? No. This is of the earlier runs. So okay. So just to compare this later on, we can copy this last bit over here. So it will say total bounding boxes how much? 3615, and then we can compare as to what it is given as output. Okay. And to just quickly go through that, so 200, I'm sure it means however many runs, and the average loss and these things it was showing us in the uh, so this is okay. Itna hours left because obviously I've given the max as 200, right? So the max value here is 200 for the max batches, and now this has become test 3. So test 3 is what I want to do with 200. uh, I will go ahead and increase this, and I'll probably run another test now, which I'll put in as maybe 600. So let's see. Yeah, and again the weights are here. We'll just put this as test 3 and continue. So that's okay. That I can do later on. I want to see this. What does this show? Shows nothing. Right. So obviously this 200, 300 max batches is not working out for us. Just 200 iterations doesn't probably give us anything useful. So need to run it for a longer duration. So okay, I think this is the probably the best resource for understanding the configuration file. So it says configuration parameters in the net section, and this is the wiki, the official wiki. So Alexander AB. So AB is his actually his full name, right? So Alexei is just because he's Alexander, so he probably calls himself Alexei, which reminds me of a cousin brother of mine, Alexander. But any which ways, that's a different story. Okay, so batch one, number of samples, subdivisions. Okay, this we've already understood. Width and height already understood. Channels, okay. Image channels input, okay. Contrastive. This I have not seen in my file, so I hope I don't end up missing out something. But contrastive and all this is not there, right? Saturation, exposure, hue, angle. So angle is so if you want augmentations, so there will be a flip, right? Flip image angle, but that is okay. We can just leave that. And then this we don't have, right? For training only it says, but I don't know. That's not there. Supervised contrastive loss for training classifier. Data augmentation. This we understood. Saturation. Okay, randomly change saturation of images during training. Uh, do I want this? I don't know. I just want to quickly do a training. This thing. I probably maybe this will take more memory. I don't want any kind of augmentation or transforms happening right now. So what we call transforms, uh, usually for the PyTorch framework, over here, this is all being defined over here. I don't want any of this. This also I don't want. Right. So maybe the default values are not zero. I'm not sure, but uh, I don't want any of this right now. So maybe we'll just keep it at that. So optimize. Okay. So momentum, fine. The accumulation of movement, how much the history affects the further change of weights. Okay, and what is it that I've written over here? A parameter momentum used to penalize a large weight change between iterations. So this is obviously not very clear. So we'll keep it here and we'll add this. Right, or yeah, I've already put this on top, right? I've just put this on top over here. So which is okay. So we can leave that for now. I will not comment anything else in this file. Too many comments already. Okay. And then DK, VK, weaker updating of the weights for typical features. It eliminates disbalance in dataset. Okay. So this also got to do with optimizers. Mm, okay. Yeah. So this one I've gone through. So this I understand from optimization point of view. So this is all the optimization and scheduling and the schedulers which are there in PyTorch. They're similar to that, right? So learning rate already done. So burn, yeah. So this is it. So what we are calling burn here is what we are calling warm up in mm, PyTorch, right? So burn in, right? 1000 burn in. It's called warm up over there. But then we don't want the value 1000. Obviously, 1000 doesn't seem to be okay for the first 1000 iterations. Eight and iteration burn in by default. Okay, so obviously this will current learning rate will be calculated, uh, and the learning rate will be multiplied into the burn-in. So it seems a lower value of burn-in probably would be okay, right? Because iterations divided by burn-in. Iterations. So this calculation I'll have to check. I'm not able to make it out right now. But what I'll do is I'll keep the burn-in low, and I say 1000 is the default. Um, but for now, I'll just keep it as what, I don't know, 10 maybe, because that warm up and all I remember. So for certain periods, say 10 periods, or whatever this value is, after that it'll start off changing, is what I remember. Until then, it'll remain constant or something like that. Okay, so keep it as 10 for now. And policy steps is understood. Policy for changing learning rate. Uh, okay, the training will be processed for this number of iterations. So yeah, max batches is training will be processed for this max batches. Okay, so this is obvious. This shows in that image also. Sorry, in that chart also, bottom right, we can keep on seeing this. This keeps on changing. Bottom right in the chart. Yeah. Now we can see loss being plotted. Okay, this was not happening earlier. So whatever it is that I have changed now for the current one, we can see this. And the max iterations is still at 200, right? But there's definitely, uh, yeah. So it will quit now. Automatically, it will quit. So this I need to again save and compare from what I've done earlier. So this is the one from the latest run, and if you look at somewhere about 140 iterations, right? So what is this value of loss? This value of loss is somewhere about, I think it should be 1 point something. 1 point, I don't know. let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So it's almost in the middle, 1 point something. And this is say around 150, right? So within 150 we are saying 1 point something. So if I what I did, I took a I copied this terminal. I'm unable to pipe it into a log file or something. So for now I've just copied this terminal print of mine, and if you were to look at this, it's giving me around 104 value. So this is 149. So the last one I couldn't capture the top, but so I am presuming that is this is 150. So that one is 148. So around 149, 150. The value is 1.6, 1.69, right? So does this make sense? So can I say it would be 1.69 over here? I think so. Yeah. So okay, and then again, then it goes up. So there is not much of a variance, so that we can't really probably see it very well. I'm not sure, but let's try. So then around 200, what happens if I go to the end of this file? This 200, that is 0.84. So if around 200 it is 0.84. So is this less than 1? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No, doesn't seem that way. It seems to be more than 1 to me. I'm not sure. So anyway, yeah, so average loss it is saying on 200 is 1.11, right? So average loss is where 1.11. Okay, 1.11. Yeah, this figure matches, right? So the average loss matches on 200. So okay, so yeah, this is how this is to be understood. So I think it is probably the average loss that he's plotting over there on that chart, right? And not this first figure. I'm not sure what this first figure is then. So this we need to make out. That is one thing. And then these images now got saved. So what I'll do is I'll take up these images and I'll take them from here and I'll put them into the backup with call it test3, test underscore 3, and I'm sure there is some way of automating all of this. Could write some custom code, or maybe uh, within the library itself there'll be a way of putting your various test runs into different directories and things like that. Obviously this is very random, just putting everything in backup, and not so maybe I don't know how much of it is written in Python, how much in C or C++ or whatever, but C++ I can't get into. Python I would definitely want to just create a directory over there, and uh, so that things will be more organized. Okay, so yeah, so this is it. Let me come back to this now. Another thing which needs to be noticed is tensor cores are used, right? So earlier it was giving us that only after 3000 iterations or something tensor cores will be used, and now for this entire lot, at least for the last 50, I can definitely see that tensor cores are used, right? So I have uh, 52 approximate that I could copy out of my terminal. Otherwise, rest of it is gone. So I really want to pipe this somewhere, and then somewhere I saw that you can store it into a log file by tailing the log. So I saw somewhere some t log or something happening. So I'll again check on that. So tailing the log should be possible, and saving it. Also, because I have removed the map, now let me try with the map. Does it give me a challenge with the map with all this optimized configuration? Let's see. Maybe it runs out of memory. Maybe it doesn't. I don't know. Doesn't seem to be running out of memory now. Yeah, earlier it was not running at all. See what a sudden drop is there, and this sudden drop, then it continues. Then it kind of doesn't really change much. What is 0%? Something 0% came up over here, right? Oh, this map. Oh, the map was earlier not being plotted, it seems. Now it is being plotted, right? So let's see what happens. Map is 0%. Okay, so the mean average precision. that is what was not being calculated, it seems, and maybe that calculation is GPU heavy, so that's the reason earlier we were getting that CUDA out of memory errors, but now that is not happening. Okay, so let me go through this again and come back. Okay, another thing that I've noticed on the official wiki, so over here, right, so there are different wikis, right? So there is this one for train detector on MS Coco. So yeah, this is the one. So over here, he mentions that 32 GB GPU VRAM set subdivisions to 8. So what is the batch size? The batch size would be 64, right? So where the batch size is 64, over here in this Yolov4.cfg, he said that go ahead and set for a 32 GB RAM subdivisions as 8, and then subdivisions as 16 and 32 for anything between 8 to 12 GB RAM. So I just have 4 GB RAM on my system, right? So if I set my, let's say, I put this as 64 as recommended by him, then my this value should be less than 8. Sorry, less than 32 is what I presume, or greater than 32. 64. No, but obviously not 64, right? Because 64 divided by 64 will be what? One image would go through. So this seems to be okay for me for now. Wherein, I am giving 6 as the batch size and subdivisions as 3, which means 3 images are going through in one iteration. Uh, for a 4 GB RAM is what I'm thinking. This is okay. Yeah, fine. Then continuing again with this mean average precision, the map values, and why. Then another thing I've noticed, I got this best weights file now. While I've run the mean average precision, along with the mean average precision, where I did not have this flag map in the end, I did not get this best weights. So maybe it is because of that flag, or maybe something else. Let's see. And now I'm trying to run inference, or trying to run test with that. What I got in the backup as for test 3, right? So for the final that YOLO for custom final weights, I'm trying to run inference on that now, and that would be this file. And this is the command that I've created. I've just put it over here. Okay, so let's run this. So for now, again the same issue. It has got my that file up here, but it has not given me any. It's not given any prediction, right? So this is the usual printout that we'll get, but here once the image comes up and you start getting the bounding boxes, that does not happen. So the other thing to notice is that while I ran this with the final weights, so there's a difference when I run it with the final weights from that test 3 run, and also when I run it with the best weights, right? So this is the best weights. I do not run the best weights otherwise earlier, and the final weights when I run it. So this one is the run for the final weights, and when it is final weights, over here it is showing okay, fine, final weights, and there it says scene 64 trained 1, right? Uh, so is it 1K images or one? I'm not very sure, but any which ways, that is what it says. And now if I were to search for this, and if I come down here, I see 0, right? And when I go up, what I was experimenting earlier with that, pre-trained YOLO V4 convolution 137, and then also it said 0. And over here we need to note that it says 137 layers from weights file, right? And in my latest one, it is telling me there are 159 layers from my weight file, right? This is for the final one, and below also it takes 159 layers only in the best case also. So my custom this thing is training 159 layers, and over there were 137, right? So on this best also, nothing happened on this image, even though it says predicted in itna milliseconds. It doesn't really show anything, and the no bounding box. So either the training is not good enough to show anything on a test image, that obviously it is not showing any bounding boxes, or maybe there is something else which is wrong. I need to fix that.